as you saw in the previous lecture, we discussed about the multiplexer concept and demultiplexer concept. Those are the combinational circuits. Now moving on to the next combinational circuit, we have binary encoder and decoder. So if you have studied binary, multiplexer and demultiplexer, this everything is same to same, just few things will change. What are the changes and what things will be changing, I will just explain you that here, and I will explain you a short way how those things are being changed here. So see here in the diagram, what is the basic diagram which we have written in the diagram. So we have written 2 is to n, 2 power n is to n. So encoder means, now let us just try to see like difference, okay. Mux and here encoder, okay, demux and decoder, okay. So what we had here, 2 is to 1, 2 power n is minus 1 is to 1, which is basically 2 power n is to 1 itself, but to understand we will write like this, because the variables will be taking one number extra, right. And here what we have, 2 power n is to n, instead of 1 here n is happening. In demux what we have, 1 is to 2 power n, so here what will be happening, n is to 2 power n, okay. So see here the same thing, here instead of 1 you will be having n. So what thing will increase is only your input lines and output lines, in vice versa, each in different things. So here what will have, instead of only one output like we had in demux, we will be having n number of outputs. So n number means not like so many, what number is specified in this here, like 2 power 3 is there. Suppose you had 2 power 1, so you will have 2 is to 1 encoder. If 2 power n like 2 power 2 means 4 is to 2 it will be. Similarly 8 is to 3. Same thing, just do ulta, that is 3 is to 8 or 2 is to 4 or 1 is to 2. So that's what the difference is there. So I won't be solving anything like that, you don't have anything much to solve here. Even if there is anything to solve, it will be like same thing will do. So see here, we have binary encoder using 4 is to octal to binary encoder. This is one of the most important thing which they are. So here 4 is to encoder, right, 4 is to encoder. So few things which, only the things which you which might be new to you, I will just explain that. So see here, 4 inputs, 2 outputs according to the ratio, and inside you have to write encoder. So now A, B I will take as my output. Now see here, A and B is my output, right. So here I have input what, D0, D1, D2 and D3, right. So now how you will do it? So see here, this is very simple. So each time only one will be active like this, so remaining all are 0. How we had in demux, it's like that, okay. Now see here for A and B, now for then A and B, what you have to do, this thing will be same, 0 0 0 1 1 0 1 1, okay. Same thing we are writing. Now how to get the expressions, okay. Output A is equals to what and output B is equals to what. Now as you can see here, for A, now what is active here in A, that is your this. So D2 is active and D3 is active. So what you will write, D2 plus D3. Now in B what is active, D1 is active and D3 is active. So you will write D1 plus D3. The same thing I have written here. So you can see here, A is equals to what is active, so those things I have written here, and what is not active we don't write. So 0 0, right. So if it is 1 1, if it is 1 C which is active, it is 1 C which is active, and write that we will add. How to do the truth table for that? So the truth table itself is also given here. So just write like this, A and B. So you won't add these two outputs again, because we need two outputs, right. So don't get confused, and in multiplexer, demultiplexer and encoder and decoder. Similarly now we have for 8 is to 1, I have written small over here, you can just zoom in or just take screenshot and zoom. So see here, D0 to D7, A, B, C, D. Now how this thing will happen? So see here, one by one I have written like this, 1 1 1. So let me just highlight that here, or else if it's not required. So see here, everything is 0, here only like this it is 1. Now see here, A, B, C. So this part, normal truth table how we generally write, we have put like that. So wherever it is 1, that is active. So now you can see here, from here 1 for A, 4 things are active from here. So what are active? D4, D5, D6, D7. Similarly for B you can see here D2, this is the D2 line, this is D3 and D6, D7, and for C you can see here D1 is active, D3 is active, D5 is active and D7 is active, like that respectively. So here we don't have select line, so don't get confused, right? So you have to draw the logic diagram for these 3 things, and just draw the logic diagram and finish the thing. So even here you have another same thing. So 4:2 encoder, same thing we have here. Now here one thing what we have here is, so see here first line is like we have what to say here, this is x don't care condition, and this V it is 0 here. If it is 0 then it is don't care, if it is 1 we will have this normal 0 0 0 1, but here one thing what differs is the numbers over here, it differs over here. Okay, so these numbers are acquired from one place. This is one separate topic or separate kind of question that I will discuss in any other lecture while solving some problems. So don't focus on this, just see how this binary encoder is done. Now moving to binary decoder, just the reverse of this we have to write. Okay, so see here now we will be having n/2 power n. So how what we said, it will be either 1:2, 2:4 or 3:8. Okay, now we have some important questions in decoder, like they will ask we are using 3 octal to, like we had here octal to binary decoder using 4:2. So for that we did here from here from 4:2 octal to binary encoder we have written here. So see here binary encoder 4:2 octal. So from 4:2 we made 8:, here 4 should come. Okay, I made it as 8:4. Just draw this and finish it. Now same thing, these places will replace here. So now suppose let me take example of this. So if you have 2:4, you will having 2 outputs. Okay, and here 2 inputs you will have. Suppose that is A and B. So you will be, so for this how will be your truth table? So see here A B. So A B again you have to write same thing, the same truth table of encoder. You just have to place the places. So there we had A B last, here we will put A B at the beginning 0 0 0 1 1 0 1 1, and here so y0 y1 y2 and y3. There we wrote d0 d1 d2 d3 like that. So here we will be having y0 y1 like that. So 1 1, so again same cross cross like that. So see here like this you will get your output. So here to write your output, so here you will get expressions to write your output. So y0 is equals to a bar b bar, and y1 is equals to, just see here a bar b, a b bar, then a b. This is your y2, this is your y3. So this is how you get expression. Similarly you do the same for 3:8 decoder. So you will be having a b c. I'll just write fast here 0 0 0 1 2 3 4 1 2 3 4. See here now y0 y1 y2 y3 y4 y5 y6 and y7. So one here, another one here, this one here, this. So this will be your outputs here side, and remaining all you have to fill with 0 and just put like, so the equation, so simple, just write this equation. So a bar b bar c bar, a bar b bar c, a bar b c bar. So from this thing you can write at wherever 0 is there, same thing you write ABC 7 times. So according to this, then you see first one. So all 3 are bar, so put bar for each term. Only for A B in the second, then only for A and C, then A here only B C, for only for B, and here only for C. So like that you put the bar and finish your decoder. It's very simple and easy, and it's very easy also for us. The same thing will tell you, as you saw here, we had the D0 to D7, and here 1 1 1 was there. That will and from here ABC we will see which is active, we will take that and add. So just shift this table here, and you will get your output side here. Instead of D, put Y, and that finishes your binary encoder and decoder. So sometimes they'll also ask you like using full subtractor. Now if we recall from our previous lectures, so for full subtractor, now you can see here is the truth table for that. So just let me write the truth table. So give a moment. So this was your sum and this was your carry. So sum is 0 1 1 0, see here, and then 1 0 0 1. Then carry, it will be your 3 times 0 from top, 3 times 1 from here. If it is 1, you put 0 here, and if it is 0, put 1 here. So this is how I carry. So now you have to draw this, right? You remember how we did in demux, just which is here we'll took like that. So just write here y0, y1, y2, y3, y4, y5, y6 and y7. Now for this is for your sum will keep, this is for our carry will keep. Now see sum. So y0 is not there, y1, y2 is there, okay, y1, y2 is there. Then what we have, y3 is not there, y4 and y7, y4, y7. Remember we did using demux, we did subtractor, full subtractor. Here we are doing adder. So see here, and in for carry we have first y1, y0 is not there, 1 2, y3 is there, okay, y3. Then we have y5, y6 and y7. So y5, y6 from y7. So just write your sum like this and carry like this. Don't forget to write here 3:8 decoder, no select lines, and you will be having your 3, that is your A, B and C in. So that's how you do your binary decoder, this like that. So this question might be asked, so just focus on this question. If you have not understood, just try to write once. While writing, after writing, just listen to the lecture once again, you will be able to understand. So everything